Today, we will begin by understanding what a passive house is and explore the core principles behind this building standard. We will then dive into a specific passive house standard, including how they apply to new builds and retrofits. Next, we will explore the benefits of passive house design, focusing on energy efficiency, comfort, and sustainability. We also cover the NFIT, which is the standard for retrofitting existing buildings to passive house standards, and walk through a typical NFIT retrofit plan. We will then look at a different passive house classes, which will help us to understand how various levels of energy efficiency and self-sufficiency can be achieved. Finally, we will wrap up by discussing the economic implication of passive house, including its long-term benefit, cost effectiveness, and potential savings. But before then, I wanted to introduce you our team. Our team is spreads across Worcestershire, Cambridgeshire, Wales, and Rome. We are architects and certified passive house designers. We are sustainably focused and deliver high-performance result that suits our clients' needs, whether there is an eco retrofit and historic buildings using natural building materials, a high-tech new build with renewables and heat pump, or anything in between. We take a client-centered approach to ensure that our design is tailored to the project-specific context and requirements, so we can achieve the aspirations set out at the start. So, what is a passive house? Passive house is rigorous performance-based building standard that prioritize energy efficiency, comfort, and affordability. Unlike conventional designs, passive house focus on minimizing energy use while providing unparalleled indoor comfort. By adopting passive house principles, buildings can reduce their energy consumption for heating and cooling by 90%, significantly lowering energy cost. Beyond those numbers, those homes deliver a healthier and more comfortable living environment through consistent indoor temperatures, improve air quality, and reduce noise levels. The standard isn't just about individual buildings, it's vital tool to supporting global decarbonization goals, reducing reliance on fossil fuels, and paving the way to net zero future. As said before, passive house is not just a design style, it is a rigorous building standard, and it's grounded in science and applies universally to homes, offices, schools, other buildings, you name it. It starts with the fabric first approach. What does it mean? It means that a well-designed building envelope has a long lifespan and it will guarantee a low energy demand. At its core, we have 5 principles that work together to achieve those goals. Insulation, by using high-performance insulation and keep the indoor temperature stable regardless of the weather on the outside. Airtight construction, this prevents drafts, leaks, heat escape, ensuring controlled, comfortable indoor environment. Did you know that 47% of the heat loss is through air leakage in modern buildings? High-performance windows, often triple glazed. These windows balance solar heat gains with minimizing heat loss. Heat recovery ventilation. The system efficiently recycles heat from outgoing air while supplying fresh, filter air to maintain air quality and comfort. Thermal bridges reduce design. By carefully analyzing all thermal bridges and reduce them to a minimum, we can further reduce the heat loss. Those principles create buildings that are not only energy efficient but also incredibly comfortable and healthier to live in, with consistent indoor temperature and excellent air quality year-round. When applied to retrofit projects, these principles help to transform older buildings into high-performance spaces without compromising their character. So, what are those passive house standards? Passive house standards are focused on measurable outcome, which include heating demand. So, the heating demand is capped to 15 kilowatt hours per square meter per annum, which compares to a conventional home built to current building regulation standard where gonna have a 70 kilowatt hours per square meter per annum, so significantly less for the passive house. Same applies in terms of domestic water, where passive house is around 10 to 20 kilowatt hours per square meter annum. A conventional home goes between 30 to 50 kilowatt hours per square meter annum. Same applies for the cooling demand. And then the other criteria is the primary energy use. Here is divided in primary energy and primary energy coming from renewable energies. So in the first case, it is capped to 120 kilowatt hours per square meter per annum. In case of renewable, is 60 kilowatt hours per square meter per annum. These criteria are regarding the classic passive house. We're going to see the classes later on in this presentation. I just wanted to highlight that if we look all on a conventional building built today to building regulation standard, the primary energy demand is going to be around 250 kilowatt hours per square meter per annum. When we refer to primary energy, we refer to the demand of a building regarding heating, hot water, any appliances, any electricity they might use. The last criteria that we have to the passive house standard is the airtightness. The airtightness ensures that the building envelope minimize the air leaks. The standard required for passive house is no more than 0.6 air changes per hour, which is significantly less than what current building regulation allows, which is around 8 air changes per hour. And as said before, the air leakage are causing 47% of the heat loss in modern buildings. All those metrics, which makes the passive house building so energy efficiency, by targeting this standard, you can achieve a consistent high performance result that benefits both occupants and the environment. So let's see what are the passive house benefits. So the passive house can guarantee building performance. Often there is a gap between the energy performance on the APC certificate and how a building actually performs. Passive house ensure performance by checking the quality at every stage of the process: design, construction, and handover. In response to the climate emergency, passive house reduces carbon emission by cutting down energy demand. It is more cost effective to save energy than to generate it. Support the fight against climate change. Improve health and well-being. Passive house homes ensure a better indoor quality, eliminate cold homes, and reduce pollutants, resulting in a healthier environment and improve quality of life. Happy occupants. In commercial spaces, these homes increase their productivity, reduce absenteeism, and improve learning outcomes, making them more comfortable and conducive to well-being. Financial advantages: lower energy bills, reduced maintenance, and high property value are key financial benefits. Passive house homes help to tackle fuel poverty and offer significantly long-term savings. Social benefits: these homes improve public health, sustain health services, upskill the workforce, and align to global sustainability goals, contributing positively to community. Benefit is the passive house standard for retrofitting existing properties. The set of criteria are similar to passive house standard, but it takes into account that some of the aspects will be hard to be achieved in a retrofit context. So mandates reduce standard for heating demand and airtightness. The principles are the same and based on building physics, ensure durability by managing moisture, condensation, material breathability, reduce the maintenance risk, and maximize long-term savings. Why is it important to retrofit correctly? Because it helps us to preserving heritage, enhancing existing heritage building, help to maintain the cultural historical significance, allowing them to continue being part of our shared history, reducing embodied carbon by renovating rather than demolishing and rebuilding. We significantly reduce the embodied carbon associated with construction, contributing to ensure sustainable future. Future-proofing. By improving the energy efficiency of the existing buildings, we ensure that they are prepared for future needs and challenges, making them more sustainable in the long term. Housing delivery. By improving and converting existing buildings, we can help meet housing demand more quickly and efficiently, making better use of available resources. It is worth noting that a retrofit project does not need to be done all at once. It can be carefully planned, and it can be done in stages. As stated before, it is important to make improvement to the fabric first. With insulation, improved windows and doors, considering the airtightness and ventilation. Only when the energy demand has been lowered, we can introduce new heating system and renewables. In the diagram on the right, you can see how much the energy demand has been decreased through the retrofitting steps undertaken, saving up to 93% of the energy at the end. There are three categories of passive houses. These relate to the whether or not there is a renewable energy generation as a part of the scheme and how much is produced. With a classic passive house, we have a low energy building that relies on the grid and supply energy. With a passive house plus, enough renewable energy is produced to supply the demand for the buildings. The premium passive house instead produces more energy than it needs, allowing surplus of energy to either be stored or sold back to the grid. And finally, why we think as passive house it is a smart investment. Because it's sustainable. Passive house building reduce environmental impact by minimizing reliance on fossil fuels and along with net zero emission goals. These homes are designed to last, offering energy efficient and future proofs them against the rising energy costs and changing climate regulation. Affordability. Energy bills often feel like a second mortgage, but passive house reduces heating and cooling demand by up to 90%, significantly cutting those costs, while the upfront construction cost is 8 to 10% higher. That difference can be recouped within 8 to 10 years, thanks to the ongoing energy savings. Plus, passive house homes have higher resale value, sometimes as much as 20 to 25% in certain areas. And with the government grants and subsidies, these homes become more affordable from the start. Although passive house homes cost more to build, between 18 to £2,500 per square metre, compared to a conventional home, that cost around 1,200 to 1,800 pound per square metre, the long-term savings are worth it. Lower energy bills, reduced maintenance and higher resale value make passive houses a smart, sustainable investment. With proper planning and integration from the start, the cost difference can be minimizing, making the financial benefit clear over time. Thank you for watching this, and I'll invite you to subscribe to our newsletter where you can find already our published articles and any article we're going to publish in the future. Thank you very much.